This is Jack Jackson. In this video, this will be the the fourth and last of our little series of videos on compositions of isometries, where we're looking at all the different possibilities. The first and longest one was on reflection first. The next one on translation first, the rotation first, and now we're going to do if you do a glide reflection first. So notice that there are all together, there's 16 combinations of this, 4 choices for the first isometry, 4 for the second, but some of them had subcases depending on some of the conditions. So let's first look here at a glide reflection first. Remember how a glide reflection works. You define a vector here that's going to slide the original figure. Then you have a parallel line where you reflect the intermediate image to get your final image here. Now that's actually really just an intermediate image because that's the result of the first glide reflection. Now we apply the second one, which is going to be a reflection. Now, let's see if we can predict what's going to happen before we even see it. A glide reflection is essentially 3 reflections, and the reflection will be a fourth one, or two odd isometries. Their product is an even isometry. So the even isometries would either be a translation, rotation, or identity. I know it's not going to be the identity because I know what the inverse of a glide reflection is. It's another glide reflection. So it's either going to be a translation or rotation. Okay, so we know at least that much. So let's see. It may depend on how where the reflection, uh, if it's the same mirror line, parallel, or intersecting. So we may have different results here. So first of all, if it's the same mirror line, where's your final image? Well, it's back at where the result of this translation, right? And so the resulting transformation is just a translation by the original vector. Okay. Well, what if it's a parallel mirror line? Okay, now we have this mirror line here. We're going to reflect, let's take these away. We're going to reflect this intermediate image, the image from the first glide reflection. We're going to reflect it over this line here. Now I've done it so that this is parallel. So how do we get from here to here? Well, we can connect pre-image to image points, and we can see, if you look, those appear to be parallel in the same length. So it looks like the resulting transformation is actually a that one looks like a translation, but it might be, yep, that's definitely a translation there. And there's the vector here. It's also, these are also copies of the vector there and there. Okay, so what do we know about this? Well, it's interesting if you break that vector into components, one going parallel to to either one of these, the original line or the parallel mirror line, you get the original vector as that component. And the other component is going this way. Well, what do we know about that? Well, its length, in this case, it's 236 point something. This is about 118. If you look, it's twice as big. So this smaller length is the length between the two mirror lines. The longer length is twice that, and that's the component in that direction. So if we wanted to sort of go backwards, the end result for this vector here is the component here and then here. then this mirror line here must have been half the distance of this perpendicular component. Okay, so anyway, there's our intermediate image. There's our final image. What happens if the line is intersecting? So this time the line is going to intersect the mirror line is going to intersect that one. The way this is moving around, of course, it could generate to the same line. That's just a translation, but what do you think? Is that a rotation or a translation? Those are really our two options. Well, it's going to be a rotation, I think. We should be able to see that by connecting up pre-image to image points. These are not parallel. The midpoints are not in a line. But if we look at their perpendicular bisectors, they meet at a common point. That common point will be the center of the resulting transformation. So if I clean this up a bit and take some of this away, the final result is a rotation about that point. And you can kind of see the circular paths there. Notice that the angle made by the two mirror lines, the mirror line from the original glide reflection and the mirror line from the reflection, which was performed second, that angle there is half as big as the angle of the rotation, or the angle of rotation is twice the angle made by those two mirror lines. Interesting, huh? Okay, so that's if we have a reflection second. Glide reflection first and a translation second. Okay, before we even go any further, there's the image, intermediate image, and the image, which is going to be an intermediate image, but it's the final image of the first glide reflection. And then we're going to take that image and translate it. Now, first of all, let's see what's going to happen here. A glide reflection is 3 reflections. A translation is 2 more. So that's odd. So we're going to end up with an odd isometry. That's either going to be a glide reflection or just a reflection. So most likely we're going to get a glide reflection out of this. If the conditions are just right, it might be just a reflection. So let's see what happens here. So here's our translations. The vector could be parallel or not. So let's look at parallel vector. So here's your vector that's parallel. What do we end up getting? Well, we end up getting a glide reflection, right, with the same mirror line. And the vector is just the sum of these two vectors. So if you add that vector and then add this one to it, you get the vector that's going along here. Of course, if they're opposite vectors, let's see here, then what do we get? That gets the identity. No, it doesn't get the identity. It gets just a reflection, right? So if these vectors are opposite, if this vector is the opposite vector of that vector here, they essentially cancel each other out, and you just get a single reflection. So if it's just right there, with the opposite vector, we'll get just a reflection. But otherwise, we get a glide reflection. Okay. What about a non-parallel vector? So actually, I could make this one parallel. This is just inner vector, but let's say it's not necessarily parallel. Let's say it's going this way, for example. Okay, so there's the final result. How do we get from here to here in one step? Again, it's going to be either a reflection or a glide reflection, most likely a glide reflection. So let's see. Yep, sure enough, it's a glide reflection. So let's see if we can figure out what's happening here. Well, notice that the mirror line for the glide reflection is parallel to the original mirror line for the original glide reflection. What about these vectors? Okay. So ultimately, so what we do is we take the component of this guy that's parallel here and add it to the original vector, and that gives us the vector, and then you reflect over this line, you'll get the final one. Well, what about the vertical or the perpendicular component? It's twice the distance between the original mirror line and the new mirror line. Okay. What if we do a rotation second? Now, before we even look at this again, a glide reflection is an odd isometry, a rotation is even. Once again, we're going to have an odd isometry out of this. We're going to get a glide reflection most likely, or possibly, if the conditions are just right, it might turn out to be a reflection. So, so this one, we need a center for the rotation and an angle, and then that produces this final image here. So we're rotating that by something. Let's say rotates to here, for example, the center. Okay. So now the question now really becomes, how do we get from the blue one to the red one in one single step? It's either going to be a reflection or a glide reflection. It looks like just going to be a glide reflection here. So we should be able to see that by connecting pre-image to image points. Notice that the midpoints of those are in a straight line. They're not parallel, but those midpoints are in a straight line. That's going to be your mirror line for the glide reflection. Reflect the final image back over that line to get the intermediate image from the glide reflection, and there's your vector. Okay, a lot of stuff going on here. So the mirror line here is not the same as the original one. It's rotated. And if we look at, let's see if I can measure it here. Let's find the intersection of these two and then measure this angle. Notice that that angle is half of the original one. Okay, so we're rotating that that's going to be rotated at half of the angle of the rotation, half of this angle, and we get that nice relationship. But the easiest way probably to see it is to just look at the final image and the original image, get these line segments connected from pre-image to image, look at their midpoints, connect them up to be the mirror line. Okay, one more thing. A glide reflection and then a glide reflection. Now, if we do this just right, we're going to get the inverse here. And if it's, but otherwise, what can we get? Well, odd and odd, we're going to get an even isometry. That's either going to be the identity, translation, or rotation. It's going to depend about how these mirror lines compare. So first of all, what if we have the same mirror line, and then we have a vector here? Well, it's either going to be Okay, so we have that. And then we're going to reflect it over that original line. Now, if this vector is exactly the opposite, then the final image will be exactly the original image. So that's how you can get the identity. So in other words, the inverse of a glide reflection is a glide reflection with the same line but the opposite vector. But if it's not, it looks like we're going to get a translation, and the amount of the translation is just the sum of the two original vectors. So you have the vector from here to here, and the vector from here to here is the same as the one from here to here. And so the end result is just translation by that vector. Okay, what if they're parallel mirror lines? So let's see what's going on here. So once again, if we start by translating and then reflecting, there's our glide reflection. Take that one and we want to mirror image it over this mirror line, let's say here, to get our final thing, but we're going to also translate it first. So you translate it and then mirror image. That gives you a final image down here. Well, again, the question is, how do we go from this original one to the one here? We know it's going to be a translation, a rotation identity, clearly not the identity. I think we can see it's going to be a rotation. So let's see, let's verify that. So if we connect up pre-image to image points like this, oh no, it's actually going to be a translation, isn't it? Okay. It's actually, yeah, it's actually a translation. If we connect up pre-image to image points, those are all the same length and parallel. So yeah, that's a translation. Okay. So how does that compare to what we started with? Um, what's the vector for that translation? This vector here. Well, let's see. We take the original vector here. If we break it into components this way, um, it's harder to see. Oh yeah, we got these two vectors here. Okay, so if we add these two vectors together, we get the component going this way. So we would get going from here to here, and then going from here on will give us the component in this direction. And if the component, maybe I need to see that, I need to see. Okay, so if we look at this vector here, that's the same as the green one down here. See that? Okay, so you sum the two vectors, that's the vector going component parallel. But there's also a component going this way. Well, if you find how far apart the two mirror lines are, I think we're going to double that to get the component this way. So that's the component going, let me just do it as a segment, not as a vector, but from here to here, if we find that length, let's check this out, see if this works. That length there, yep, it's twice the length from here to here. That orange one is the length from here to here. From here to here, it's twice. Should work out. We move it around. You can see the twice going on there. So what do we get? In the end, we get a translation. Glide reflection about a parallel mirror line gives us a translation. Okay. Same way for the same mirror line was a translation or the identity. What about intersecting ones? My guess is a rotation. Let's see here. All right, so here we have a glide and a reflection. So there's our intermediate image once again. Now for our second transformation, we have another glide reflection. This time the vector is not necessarily parallel to that, so the mirror line is likely to intersect up here somewhere. Okay. Let's do it like that, for example. So what's going to be the finals? We're going to reflect that over that line there. Here's our final image. Okay. What's the resulting transformation? I think this is something we didn't need here. Okay. So again, if we go back to this final image, how does this one compare to that one? We know it's a translation or rotation, not the identity clearly, it's a rotation in this case. If we connect up pre-image to image, these are not parallel, the midpoints aren't in a line, but they're perpendicular bisectors intersect at a single point. That is the center of a rotation. Okay. So notice that the angle between the two original mirror lines, in this case 0.73, if you double that, you get the angle of the rotation here. So the amount of the rotation is twice the angle between the two original mirror lines there. Interesting, huh? Okay. All right, so we have now completed, finally, all of the different options for doing in this video, glide reflection first, then a reflection, translation, rotation, or glide reflection second. Notice that I did not necessarily know when I started this project what all of these things were going to be. Some of them I did, but not all of them. And this gives you a good example of how you can use GeoGebra to investigate and discover things. In this case, we just were systematic about going through all the different possibilities. It took a little while to make sure I got all the possibilities and organize this activity, but now that I've done it, you can use it to explore these things on your own, and I encourage you to get in here and look at them. So let's look at a summary where we have a glide reflection first. So summarizing what we just found, if you do a glide reflection first and then you do a reflection about the same mirror line, you get a translation. The vector is the vector from the glide reflection. Glide reflection first, reflection second, about a parallel mirror line, you get a translation. For the vector, you get the component parallel to the mirror lines equals the vector from the glide reflection. The component perpendicular to the mirror lines is in the direction from the first mirror line to the second mirror line is twice as long as the distance between the two mirror lines. It's all stuff we found earlier. If you do a glide reflection first and then do a reflection about intersecting mirror lines, you get a rotation. The center is the common intersection of the line segments from pre-images to their corresponding image points. Uh, and that should say the center is at the common intersection of the perpendicular bisectors of line segments from pre-images to their corresponding image points. And the amount of rotation is twice the smallest rotation from the mirror line of the glide reflection to the mirror line of the reflection. If you do a glide reflection first and then you do a translation by the opposite vector, you get a reflection. It's just the mirror line from the original glide reflection. If you do a glide reflection and then a translation by a parallel vector, you get a glide reflection. The vector is the sum of the vectors from the original glide reflection and the translation. The mirror line is the original mirror line from the original glide reflection. The mirror line will contain the midpoints of line segments from pre-images to their image points. If you do a glide reflection and then a translation by a non-parallel vector, you'll get a glide reflection. The vector for the resulting glide reflection is the sum of the vector of the original glide reflection and the component of the vector from the translation parallel to the mirror lines. The mirror line is the parallel to the mirror line from the original glide reflection. It contains the midpoints of line segments from pre-images to their image points. The new mirror line is a translation of the original mirror line by vector, which is 1/2 of the component of the vector from the translation perpendicular to the mirror line. A lot of words there, but this is what we found when we were looking at it earlier. If you do a glide reflection and then you do a rotation, you get a glide reflection. The mirror line of the resulting glide reflection contains the midpoints of the line segments from pre-images to their corresponding image points. The mirror line is a rotation of the mirror line from the original glide reflection by amount equal to 1/2 the amount of rotation. If you have a glide reflection followed by glide reflection with the opposite vector in the same mirror, that's the identity transformation. So that says that the inverse of a glide reflection is also a glide reflection with the opposite vector but same mirror line. If you have a glide reflection and followed by a glide reflection with the parallel mirror lines, you get a translation. The component of the translation vector parallel to the two mirror lines is the sum of the vectors from the two glide reflections. The component of the translation vector perpendicular to the mirror lines is in the direction of the first mirror line to the second one, and its length is twice the distance between the mirror lines. If you form a glide reflection first, then a glide reflection about intersecting mirrors, then you get a rotation. The amount of the rotation is twice the measure of the rotation from the mirror line from the first glide reflection to the mirror line of the second glide reflection. The center of the rotation is at the common intersection of the perpendicular bisectors of the line segments from pre-image to their corresponding image points. For my class, it's definitely not necessary that you memorize all this detail. This is a lot of stuff here. Um, Certainly, this is not all core material. However, there are a few of these that I think are extremely important, and I've kind of highlighted them in red. You need to know which ones result in identity transformations. That is, you need to know what the inverses are. So that's the main one here where you start with the glide reflection you need to know. For rotation, you need to know about if you keep the same center that you just get a rotation by adding the angles, and that if the angle's opposite, then you get the identity transformation. If for a translation, if you translate by the opposite vector, you need to know that gives you the identity transformation. If you translate by non-opposite vector, that also gives you a translation, but you're just summing the two vectors. And if you do a translation and a reflection about a parallel mirror line, that's a glide reflection. That's kind of the basic definition of a glide reflection. And for the reflection, if we need to know, basically, if you compose two reflections, we need to know what those things do. If you reflect about the same line, that's the identity transformation. You reflect about a parallel line, that's a translation. You reflect about an intersecting line, that's a rotation. And um, this was probably not quite as important. So be sure that you know those ones in red as far as I'm concerned. The others are additional information which is useful and interesting. It's given here for completeness, and it also gives you a good example of how we can use uh, GeoGebra in a systematic way to go at solving some kind of a problem. Here I really did nothing more than using the original tools, but there's a lot of work in keeping track of all the cases. Uh, but now that I've done that, you can use this to explore on your own. So now we have completed showing exactly what happens when we compose two isometries. We already knew with a pretty simple proof that the composition of two isometries is another isometry. We did some work earlier to show that there are only 5 types of isometries: the identity, reflection, translation, rotation, and glide reflection. But this little series of videos has now gone into more detail about all the possible combinations of composing two non-identity isometries. Of course, if you compose an identity isometry with another isometry, you you get that other isometry. Identity composed with reflection gives you that reflection. Okay, that concludes this little portion of our video.